Alright, so the first lesson today should not be very challenging. Okay, this whole first unit, okay, we're just going to look at linear functions and linear inequalities. Okay, so most of this first unit, if not all of it, should be reviewed. Right? Now, what we're going to start off with today, okay, is linear equations. Very first thing we're going to do is setting up expressions, though. Okay, given a set of words, how can we write an algebraic expression, and then given an algebraic expression, how can we turn that into words? So, up at the top of your note sheet is this little table. All of these different categories, right? This first one, add, plus, sum, increase by, more than, okay? That tells you that you're going to be adding somewhere in this expression. Minus, difference, decreased by, less than. Those all tell you you're going to be using subtraction. Times, product, of. Okay? That's kind of a strange one, okay? But of, as in of a number, right? That means multiplication as well. And then divided by and quotient means division. Okay? Another one that I did put on this table, another key one, is. Okay, this actually means a separate thing. Right? So if I say like 4 times a number increased by 7 is 24. What does is mean in that statement? Equal, exactly. Right? So whenever we see is, that's going to mean equal or equality. All right, so let's try one of these together here. Okay, right underneath your table is example 1, and it says write an algebraic expression to represent 18 less than the quotient of a number and 3. 18 less than the quotient of a number and 3. So first of all, if we see a number, how am I going to represent a number? X. Yeah. Okay. So whenever we see a number, right, we're going to put in a variable. The most common variable we use is x. So how can I write this whole thing then? 18 less than the quotient of a number and 3. Okay. Now the order here is kind of tricky. The order does matter on how we put these. So what do you guys think? 18 less than the quotient of a number and 3. Mike?
18 minus. It's 18 minus, but then the quotient means divide.
Is it 18 minus x divided by
Almost. So
2x.
no, there's just 1x. There's just
Throw
1x.
an x in front.
So you have all the right parts, just not quite in the right order. Okay. 18 less than this means I want to take 18 away from this. I don't want to take this away from 18. So 18 less than something means I want to take 18 away. So even though it's written with the 18 first, what this is actually saying is take the quotient of a number in 3 and take 18 away from that. Okay? 18 less than the quotient. Make sense? Are we okay with that one?
Yeah.
Alright. So we've got some to try down here. Okay, do you guys want to go through another 1 or 2 together, or you want to try some here on your own?
another 2 together.
Alright. Let's take a look. Let's take a look at. That just quit? Did. Alright. Let's try to get that back up here. Maybe we'll just go off the PDF if this doesn't like the smart notebook. Shouldn't be. right there.
What is NA2404? My cell number?
No, that's the.
Is that my social security?
Oh my God! No, it's not your social security.
Looks like it.
That's your student ID number.
Well, it's close to my social security.
That's just the code for this class.
Well, what about that one?
2400 is Algebra 3.
I don't know. I should just give my information to everybody.
I mean, if you want, you can give out your social. Might not be the best idea. I don't know what your social is.
We can get a social security card. I need one.
You don't have your social
My
security.
mom lost that, my birth certificate, all that. My birth certificate is a document. It says who my parents are, where I was born.
All right, let's try this one again. Okay, 4 times a number increased by 7. All right, so 2 separate parts here. What is 4 times a number? 4x, sure. Increased by 7. Plus 7. Does it matter if I do 7 plus or plus 7? Does the order of addition matter? Is 2 plus 3 the same as 3 plus 2? Yeah, right? So the order of addition really doesn't matter. The order of subtraction does matter, right? Because 3 minus 2 is not the same as 2 minus 3.
But it's not in the form of order. Yeah, it should be in the form of order of operation. Because multiplication.
Well, so that's a good. So if I had it written like that, okay, and I gave you a value for x, you would still do the multiplication first, and then add 7 because of order of operations, right? Even if it is written like this, okay. But technically, these two mean the exact same thing, right? 7 plus 4x and 4x plus 7 mean the same thing, all right? How about number 2 here? 8 less than 5 times a number. Okay? Not quite. So, Caleb?
Is it 5x?
Yeah. So the order here is tricky because of the way it's written. You want to, I mean, it makes sense to say, well, 8, then less than means minus, and 5 times a number. But if we're saying 8 less than this, that means we want to take 8 away from this. Right? What's that?
So it makes that one number. So it's 5x.
Right, so this 5 times a number is 5x. And then I want to take 8 away from that. 8 less than that means take 8 away from the 5x. So subtraction, the order does matter. Right, so this we would want to put 5x minus 8. Okay. You okay with those? Okay, so let's take a couple of minutes then, and you guys try 3 through 6 here. Compare your answers with each other, ask me questions, ask Mrs. Marshall questions. Right, there are a couple of these that are kind of tricky. Like numbers 3 and 5. Okay, you might be missing one small piece on these. So for number 3, okay, it says 6 times a sum. Okay, 6 times the sum of a number in 5. Right? So this part, the sum of the number in 5, that hopefully that part was easy, right? That means x plus 5. But then it's saying take 6 times that sum. Okay, well, if I want to show that I'm taking that sum and then multiplying it by 6, I want to put that sum in parentheses like that. Okay? So that might have been something that was a little bit tricky here. And it's actually going to be pretty similar to number 5. Okay, so double check here before we go over the rest of them. Okay, see if you've got this down.
Number 6 is hard. The way it's worded.
Yeah, this square of the number is...
I know it's going to be x squared, but I don't know. Because I know, and then I know it's going to be a multiplication thing. I don't know how you would do it.
Well, I mean, there's a couple of different ways you could write it. I mean, yeah, you're exactly right. This means x squared, and then this means you're going to multiply it by -11. So what's the easiest way to write x squared times -11? Alright, so this...
So back. Yeah.
Nice.
It's like, I don't really think algebra is good, and that's what we're doing this stuff. Which are like boring or phrasing.
Alright, so check your answers up here. Okay, what do you guys think? Any that you have questions on? Making some sense? A little bit? Alright, well let's go the other way now then. Okay, let's take expressions, or in this case, we have all equations, okay, and turn them into verbal sentences. So, I mean, you can just think about how you would read this equation, right? And think about how we wrote verbal expressions, or how the expressions were written for the last set of problems. Okay, so here we want to write a sentence to represent 6 times this n minus 2 equals 14. So how would we write that based on what we were just given? Mike, what do you think?
6 times the sum minus 2 is 14.
Oops. So wait, say that again. 6
Times the sum minus 2 is 14.
times sum. I think you left out one part. Times the sum of. You just said times the sum of minus 2, didn't you?
Yeah.
So we have to include this variable in there. So how did we include a variable? We said it was a number, right?
Oh,
So 6 times the sum of.
I meant that with the sum.
Oh, whoops. Yeah, not sum. Difference.
This is no.
6 times the difference said is 14?
Yeah.
Yep. 6 times the difference of a number and 2 is 14.
We have to write the numbers out like out of time.
No, you can use the number in there.
This lesson's not multiple and something. Like on like a paper or something.
What do you mean on a paper?
Like if you're writing a paper for something.
Oh, yeah. Is it less than 100? Is that what you're supposed to write?
I was trying to remember.
I want to say it's, yeah, that's, if you're thinking about like in English class and you're writing an essay, I think it's if a number is less than 100, you're supposed to write out the number like this. But if it's greater than 100, you're allowed to write the numbers. So if you're thinking about like English class, I think that's the rule.
My house paper was there.
Yeah. All right, we're gonna do another one together here.
Yeah.
All right. Let's do this one together. Okay. So how would I express the left side of this equation here? Let's do number 8. So how would I express this 8 plus 3x? How would I write that in a sentence? Okay.
Did you say 5 is the sum of 8 and 3 times number?
That is the sum of 8 and...
Or you could do increased.
Yeah, that would work too. But yeah, this the first one you said definitely works. Yeah, so I mean there are multiple ways to do this, right? I mean this way absolutely works. 5 is the sum of 8 and 3 times a number. Okay, or you could say 5 is 8 increased by 3 times a number. That would work too. Like
What about 8 increased by 3 and the number is
8 increased by 3 times a number is 5. Yeah, that would work too. Yeah.
5? Yeah.
Okay. So multiple correct ways that we can do this. Okay. You guys feel all right? Okay. So try the other 3 here. Try 7, 9, and 10. It's always
Every time Scrum used to English skills page, and we could do a big setup. She'd go, oh, well, then do this. And I'm like, oh, it's a big just
Do you think these ones are related?
It's really not to try to trick you. It really isn't. Wait for you guys.
Nobody's goal is to
It's crazy as hell.
No, she
But
doesn't.
she hates me and speaking back there.
You just told me you didn't do anything last year.
Okay. If you're knocking on me, it's not my bad.
Sounds like you never told yourself.
That's because I trust this guy, but now you prove me wrong.
So did you goof off so bad that you have crazy again this year?
No, I went to all my learning. And I have an A in that class. 80% head.
This one, though, this first part is the day after. Subtracted from is kind of like less than it's just the order. So instead of using that, you might want to use the difference of your groups 5.
thing was, I was just taking a robotics class, and that's why I said.
So you guys are gonna have two different answers, but that's okay because there's lots of different answers.
Can I still use it?
Well, you're gonna have to get that. Minus,
Yeah.
minus idea in there first.
Yeah.
Is where you put equals.
So less than.
Less than.
Put the grade
Yep.
there.
Huh?
Oh.
Yeah, he's
I'm gonna get
operation is that
a little bit of your hair.
he took it from me. That's where my long hair.
Yeah, that's what all my hair for free.
Well, is what divided by what?
Oops.
Is the whole thing?
It's connected to my natural hair.
It's weaved, Mikey, meaning it's braided and tweezed.
I don't know. I tell you.
Clearly.
I was
I love this way my hair. It feels so good.
All right, let's take a look at these other three here. So what do we have for number 7? And again, there's multiple correct ways to do this. Okay, Jade?
A number minus 8 is 16.
Sure, that works. Number minus number minus 8 is 16. Did anybody have anything different?
8 less than a number is 16.
8 less than a number is 16. That works too. Deb?
The difference of a number and 8 is 16.
Yeah, the difference of a number and 8 is 16. That definitely works too. All right, so multiple correct ways to do this.
Put like is equal to 16.
Yeah.
It is like more.
Yeah, I mean you can write out is equal to 16. Sure. That would be the same thing.
Because it is just aggressive. It is 16. I'm telling you.
How does is
But
equal
if I
to
say
something?
it's equal to 16, it's good.
Well, you could say it is 16. You could say it with the same tone.
No, you didn't. No.
All right, how about number 9? What do we have for number 9? How about somebody who has an answer? You three have been kind of dominating here.
I better read it.
Yeah. Okay. Mikey and Jay, you guys have raised your hand on every question.
If I don't participate, I don't get it.
I said a number plus 3 is the square root of a number.
So close.
So close. What did I mess up on?
So you said a number.
Well, start when you were born.
Stop, Mikey.
It's okay. It's fine.
Elijah?
I said the square of a number is the sum of 3 in a number.
That would work.
What?
Yeah. So you said the square of a number is the sum of a number in 3. Yeah, that would definitely work. All right, so what you just said one thing wrong. Okay, the way you said a number plus 3, you said is the square root of a number. It should just be the square. So
Square root
close.
is the little, I don't know what that thing is called.
Doesn't it actually say a number squared?
Yeah, you could say a number squared as well. The square of a number or a number squared. Caleb?
Could you say square of a number is increased by 3 in a number?
The square of a number. Well, you're so close. So if you said a number increased by 3 is the square of a number, you could say it that way. But I think the way that you had it, it sounds like it's b squared plus 3 equals b. Is that?
Yeah.
Yeah. So yeah, I mean, if you just flip those 2 things around, I think you'd be good. All right, how about this last one? How about number 10? How do we write that out verbally?
I didn't do that.
Okay. All right, there's a lot going on in this one. Okay. Mikey?
I said the quotient of a number and 3 is equal to 2 decreased by 2 minus the number.
So close.
Oh, that was right.
So you said the quotient of a number
And
and
3
3
is equal to 2.
is equal. I'm just going to write in. So is 2
Yeah, decreased by 2 minus the number.
increased by. So it's not. This isn't 2 minus a number.
Wait, would it be in or 2?
So look back up at the top.
Those are
This-
the
Oh,
and
number.
plus.
we could do So this is multiplication, right?
Yeah.
So we would need to use one of those words for multiplication. So we could say decreased by 2 times a number, or 2.
I
Two of a
think
number.
you said that, and I heard.
Right? So we would just need to make sure that we're using one of those words for multiplication. So I'll say 2 times not a number. A number.
There we go.
Okay?
Good job.
We feel okay with these? Okay. So the way that we're going to do the next couple of days, okay? And this is going to be kind of a theme for most of the year, right? In this first chapter, since a lot of this is stuff you've already seen, what we're going to do is one day of class, right, learning about something, and then we're going to do one day of like graded practice on it, okay? So tomorrow we're going to have practice problems that we're going to work on in class. You guys can work together, ask me questions, ask Mrs. Marshall questions, but then I'm going to grade them for correctness. Okay. Now, once we start getting into things that are brand new, then we'll spread that out a little bit. We'll do like one day of teaching, one day of practice, and then one day of graded practice. Okay. So that's kind of how we're going to do things in here. All right. So today is just practice. Tomorrow we'll do some graded practice. So on the back, okay, we're going to get into actually solving linear equations. Okay, again, this should be stuff you've seen before.
For give me some water.
Some water.
From
Oh, your fluxes. All right. So let's start out with, let's do number 11 together here. Okay, this one's pretty straightforward. This one's just a two-step equation. And so how would we start? What would we do first? What's our goal here?
Take 2 away from 18.
Our goal is to get the m by itself. So let's subtract that 2 from both sides of the equation. Whatever we do to one side, we have to do to the other. So these cancel out, and we get 4m equals 16.
4, or the 16 divided by 4. 4.
Right.
Hey, I was
So
getting there.
now we want to undo this multiplication. Okay, we need to take the inverse operation. So the inverse of multiplication is division. So we divide both sides by 4. And 16 divided by 4 is 4. That's our answer.
You're just taking too long.
I was getting watered, man.
Oh, sorry. We'll let you do the next one.
Alright, let's do one more together. Let's do one where we've got variables on both sides. So I guess we can do number 12 together.
Bring the 2.
Let's do number 12 together here. Okay, so first step. And there are a couple of different first steps that we could have. So what do you guys want to do first?
We just take that first x over.
Sure, that works, right? If we've got numbers and variables on both sides, the goal is to get the numbers on one side and the variables on the opposite side. Okay, that's the goal. And it doesn't matter which side you do that. Right? But we can subtract the x first. Okay? We could have subtracted the 5x over to this side. That would also work. Okay? But this way will allow us to keep numbers positive. So that will probably work out a little bit nicer.
Oh,
Okay? So these x's cancel. This 4 stays. 5x minus 1x is 4x, right? Make sure that you don't confuse this and try to cancel out these x's, right? What this is saying is 5x minus 1x is 4x. Right? And then we still have that plus 2, so now what?
then
Yeah, so now since we brought the x's to the right side, let's bring the numbers to the left side. So we get 2 equals 4x. Then divide both sides by 4. What's my answer? 1/2, right? This 2 divided by 4, okay? We can think of it as a fraction, 2/4 that reduces to 1/2, or you can put that into a calculator, right? And 2 divided by 4 is 0.5 or 1/2. Now, I've seen a lot of times people are tempted, okay, when they see these 2s and 4s, they think, well, I should just divide everything by 2, and the answer is 2.
You have to cancel a whole x out.
Right? You always want to make sure that you're dividing by that number that's being multiplied by x. Okay? So 1/2 is our answer here.
I should just minus 2t from there, bring it over 3t, and that makes it t and t is equal to 5.
Ka-chow.
This one's only one step. It looks more complicated, but this one actually only ends up being one step.
I just don't look at it.
Okay? So one thing I do want to point out here, okay, we got a fraction on number 12. Right? Don't think that all of these should just be whole numbers. Okay, we're going to work with lots of things where our answers aren't nice. Okay, so don't think that just because you've got a fraction or a decimal that your answer is wrong. Okay, it could definitely be right. Like here, we got 1/2 as our answer. Okay, so let's take a few minutes here, and you guys try 14, 15, 16. Okay, and even you can jump down to 17 and 18 as well if you get that far. Quick.
I had time for plus t. Did I mess up my board?
So what are you dividing both sides by?
5.
So
1/5 would be 4.
right.
And then there's 2 more. I need 30. 30 more plus what I have.
So what you have right now is just that, right? Either of these numbers have a factor in common. No, they don't. Right? The factors of 5 are just 1 and 5, and 22 isn't divisible by 5. So that's your answer. You can't reduce that.
Just that one give me a little more water.
What were we just saying?
So normally we'd want to do that to keep numbers positive, but if you do that in this case, you're going to put 0 over there. So I would actually put 3x.
I got 24 over 8. Because they're both even numbers.
Yeah, that's right.
So you know, they're at least
But here, 2b plus 3b doesn't disappear, but you dropped it.
So if you can't think of the largest factor, I would actually call that actually divide both by 2 and then see if there's anything left.
The second 4. Oh, and those have factor 3. 4.
Or is it divisible by 3?
Oh, wait, no.
4 is divisible by
I was thinking 4 times 4.
But it should
Yeah.
have the solution.
So they're both divisible by 4. So right now you've got 12 over 4, right? You just reduced 4 over 8. And you just told me that both those are divisible by 4.
So then I just divide them both by 4. So that'd be, would it be just 3?
You would get 3 over 1. Just 3.
Look, what do we want?
You're using your noggin.
Get the bench.
Alright, so I believe these should be our answers for 14, 15, and 16. Okay, 22 fifths for 14, 3 for 15, and 5 for 16. Okay? On number 14, a lot of people thought they had messed up, right, when they got to here, and 22 equals 5b. You can recognize that 5 isn't going to go into 22 even.
Do you only accept fractions or do you accept decimals?
Decimals are okay. Right? So if you had this as, what, 4.4?
Yeah.
Yeah, that's fine. Yeah, so if you just put this into your calculator, 22 divided by 5 and got 4.4, that is fine as well.
So like one test you would accept 4.4.
Now, that's, in this case, yes, because this is exactly equivalent to this. However, if you got 1/3 as an answer, 1/3 is not equal to 0.33, right? So it's equal to 0.3 repeating. So
Right.
as long as you are writing things that are exactly equivalent when you're writing your decimals, does that make sense? Okay. All right. Any other questions on these ones? You guys feel okay with solving these equations? All right. So yeah, hopefully my goal here was to start with something not too challenging. Okay, something you've learned before. Now these last two though, okay, these ones are a little bit tricky. Okay, there's some fractions, there's some decimals, there's a little bit more going on here in 17 and 18.
I was like, how'd you have one work for 18? I was going to say 18 different.
Alright, so we've got 5 minutes left. Let's go through these two and we'll call it a day. Alright. And number 17 here. This one's weird. We've got a minus 2a over 5 equals 3. What thoughts do we have here? What should our first step be? There's a couple different ways we can go. Jada, what do you think?
Move the 5 to both sides of the equation.
Okay, so you want to multiply both sides by 5? Like this? Yeah, that would definitely work. Okay, that's a good first step. Now, when we do that to the left side, okay, it's important that we recognize that we have to multiply both of these things by 5. Right? So that definitely works. So here we would have 5a, and then what's 5 times negative 2a over 5? What would that be? How would we do that?
Wait, the 5 would cancel.
Right.
So it would be 10.
Not if the 5 cancels out.
Oh, so it cancels out that whole fraction, like you don't times the 5 to the 2.
Right. So if we're doing 5 times, I'll write it like this: 5 times negative 2a over 5.
Oh, so you gotta pretend like that 5 is next to the fraction.
So then you just drop the 2a down.
Right. So those 5s cancel, and this would just be minus 2a like that.
You had that, I had that, but you can see we had to negotiate.
Alright? And then over here we would have equals 15. Okay? So yeah, one good strategy is if we have a fraction like that, we want to kill the fraction. So we can multiply both sides by whatever that denominator is. On this side though, we just have to make sure that we distribute. So we've got 5 times a is 5a, then 5 times negative 2a over 5. Those 5's would cancel and I would just be left with minus 2a.
Could you just times like the fraction, top and bottom by 5, and cancel out by then, and then do 2a times 5?
Wait a minute, say that again?
Do like 2a times 5 and 5 times 5, and then that would cancel the fraction. How you undo it?
Well, if you're multiplying, so you're wanting to just not multiply both sides by 5 and multiply this by 5 over 5?
Yeah.
Then we would get 10a over 25. That's even worse. Right? Because you said we're multiplying by 5, right? So 5 times 5 doesn't cancel out. You actually
But
have
it
to
does
have...
right here. It don't make sense.
No. So, here, let me do this a different way. So instead of canceling this out, let's actually do this multiplication. Okay, let's actually do this multiplication. So to multiply fractions, you multiply the numerators and multiply the denominator together, right? So I would have 5 times negative 2a is negative 10a. 1 times 5 is 5. Right?
That's fine.
And then this reduces, right? 10 over 5. 10 divided by 5 is 2. So this would just reduce to negative 2a. What I did before was just a shortcut. Right? If I cancel out a factor in the numerator and denominator, cancel out those 5s, I get that negative 2a. That is just a little bit of a shortcut. So now, this is a pretty straightforward equation to solve. Right? Now, these are like terms. I can just go ahead and combine those. So 5a minus 2a is 3a. And I can divide both sides by 3. Get 5. Alright. Any questions?